This film will cover one of the subsystems in the power plant, pumps. The pump in the power plant is a device for transferring liquids. Now, this may be water, oil, or chemicals. Liquids may be pushed, thrown, blown, or drawn by suction to accomplish this transfer. Generating station pumps are usually one of three types. They may be piston-type pumps, rotary pumps, or the most commonly used type, the centrifugal. The word reciprocating means having a to and fro motion. Thus, a reciprocating pump uses a piston or plunger which travels in strokes, moving to and fro. As the piston moves downward, the inlet valve at the left is pushed closed and the valves in the piston open. As the piston is raised, these valves close. Water is lifted and literally pushed out the discharge. Because of vacuum created by the piston upstroke, water enters the reopened inlet. Reciprocating pumps have a disadvantage in that they are positive displacement units, and accidental operation with a closed discharge valve can severely damage uses in the power plant. Applications include small volume, high pressure jobs, such as chemical feed, where high accuracy is quite important. The rotary pump, like the reciprocating pump, is also a positive displacement pump. It differs in that its pistons rotate in a circular motion as compared to the reciprocating pump. Rotary pumps use two or more intermeshing, close clearance gears which trap and charge. It shares the same problem as the reciprocating pump in that accidental operation with a closed discharge valve can rupture equipment. The rotary pump has limited use in the power plant. These pumps are generally used for small volume, intermediate, and high pressure oil, where the liquid has lubrication qualities to prevent excessive wear. The heart of the power plant is the centrifugal pump. It is as important to the generating station as your heart is to you. When it stops, so does the plant. It pumps the circulating water, boiler feed water, water for fire protection, oil for lubrication, and many other liquid transfer or moving applications. Centrifugal force is that force which acts upon a body moving in a circular path and tends to force it further from the center of a circle. Suppose you took water would be thrown a considerable distance, and the faster you whirled the bucket, the further the water would be thrown. Now let's suppose that that bucket was attached to a shaft and rotated inside an enclosure or pump casing. The velocity of water leaving the bucket would be directed against the casing, exerting a pressure on it. In other words, some of the water velocity is changed to pressure. Pressure, you recall, moves liquids. Suppose that in place of the bucket we attach to the shaft a vane-like device which we will call an impeller. Water is drawn into the center, the impeller is rotated by the shaft. The water is set in rotation by the blades of the impeller. These curved vanes throw the water with considerable velocity against the outer pump casing, and the water then enters the progressively expanding passageway called the volute. This velocity is changed to pressure along the casing or volute, and this pressure moves the liquid out the discharge. The main elements of a centrifugal pump are the impeller and the pump casing. The impeller is, of course, the rotating element. Impeller vanes are usually curved for greater efficiency and balanced on the shaft. In multi-stage centrifugal pumps, the outlet from the first impeller is connected to the inlet of the second, and so on through all stages. Each stage is practically a separate pump, although they are in the same casing, and the impellers are attached to the same shaft. The other main part of a centrifugal pump is the shell, or casing, which confines and directs the liquid. It also changes the velocity of the liquid to a useful pressure. All centrifugal pumps take in liquid at the eye, or center of the impeller. The point at which liquid enters a pump is referred to as the point of pump suction. Now, there are two types of centrifugal pump suction. They are first single suction, and next one which takes all liquid through one side. This has the disadvantage of creating an unbalanced thrust directed toward the suction end of the pump. This unbalanced condition is due to vacuum in the suction side, causing atmospheric pressure to act on the impeller, thus producing a thrust. While most pumps utilize thrust bearings, they're not usually designed to carry all of this unbalanced load. Thrust may be balanced out by, first, proper arrangement of the various stages in a multi-stage pump, and secondly, by the use of a hydraulic balancing device. A double suction pump we'd have the weight of the rotating element pushing down, which is one form of thrust. A space for packing between the moving shaft and the pump housing is called a stuffing box. It's held in place by a stuffing box gland. Wear, excess heat, improper pump operation can cause the packing to leak. This packing is important and will demand more of the operator's attention than any other part of the pump. To avoid overheating, the packing should not be too tight. Water may circulate in a jacket close to the packing to provide cooling in the stuffing box. Sometimes water under pressure is introduced to the stuffing box to prevent leakage of the fluid in the pump. As long as the sealing water at point A is at higher pressure, the liquid at B cannot get past the packing. Another form of sealing is called smothering, where hot liquids in the pump are kept from flashing by the cooling smothering water. Water may be used then to cool bearings and packing, to seal against leaks and contamination, and by pressure or by smothering. Practically all centrifugal pumps have external bearings. Some bearings are designed to carry radial or rotating loads, for example, that of a car on its wheels. That, axial or endwise loads, such as occur when a car rounds a curve. Those bearings which carry radial loads are known as line bearings and are of two types, ball and sleeve. The most commonly used bearings are ball type. Now, these have many advantages over other types, and they include the ability to take a thrust load, the lack of need for forced lubrication, greater interchangeability of parts, and lower starting torque, and of course, a shorter shaft span. Sleeve-type bearings are also used frequently in pumps for many good reasons. Sleeve bearings are more practical in larger sizes, and they're better suited for high-speed applications. However, there are several disadvantages inherent in the sleeve bearing. Sleeve bearings cannot take thrust. They also require a forced feed lubrication. When a sleeve bearing is used, there must always be some way to absorb the axial thrust. Now, this is done by the thrust bearing, and the two most widely used thrust bearings are ball-type bearings and the Kingsbury-type bearing. The ball bearing has an advantage in that it can absorb both radial and axial thrust loads. Well, now for a moment, let's turn our attention to couplings. A coupling is used to make a semi-permanent connection between two shafts. The coupling forms the link between the pump shaft and its driver, or motor. There are three main types of couplings: rigid, flexible, and fluid. If both shafts could be maintained in perfect alignment, rigid couplings like this would be just fine. But perfect alignment is not only difficult to obtain, it's also practically impossible to maintain, as inevitably slight misalignment will occur under normal operating conditions. One type of coupling designed to operate with some misalignment of shafts is the flexible coupling. Here, a soft rubber or composition material transmits torque from one side of the coupling to the other. Another flexible coupling is the mechanical coupling. It has a geared hub fitted on each shaft end. The hubs are placed in a sleeve which has internally cut gear teeth to encage the teeth on the hubs. The third type is fluid coupling. This type is gaining prominence as a means of power saving and consists of two basic parts: the input member, or impeller, and the output member, sometimes called the runner, and it's filled with a hydraulic oil. No mechanical connection exists between the two shafts. Rotary energy is transmitted through the oil. Now, obviously, the hydraulic coupling is expensive, but it does have an important feature. It can be adjusted to transmit a variable amount of torque, which means the pump speed can be changed even while using a constant speed motor. Well, now back to pumps in general. The three fundamental characteristics of a centrifugal pump are the operating speed, the total head developed, and the delivery or capacity. The three are interdependent, and one cannot be changed without affecting one or both of the others. First, let's consider speed, which is measured in RPM, or revolutions per minute. If we change the speed at which the impeller spins, we'll change both the pressure, or head, and the capacity of the pump. Speed is important in pump design and application. High-speed impellers, for instance, can create pressure in relatively small casings, which can reduce pump size. Fewer stages or impellers are needed to obtain high head pressure, and frequently the high-speed pump will be more efficient than larger, slower units. The pump pushes, expressed in PSI, or feet of water. But the total pump head is the discharge and the suction head together. In this pump, there's a positive suction pressure. But if the liquid level were lower than the pump inlet, the pump must expend work to overcome this suction. If there's air or vapor in the suction line, with this negative suction, we must have a way to prime the pump in order to get it started. Pump priming will usually be accomplished in one of three ways: with foot valve and filler, with steam, air, or water-operated ejectors, or with siphon action of the system. A foot valve, usually located at the low point in the suction line, opens only into the line and closes when suction flow stops. Priming water is fed into the pump to start, but not usually required again, unless the valve fails. The ejector uses the velocity of steam, water, or air pressure to create a negative pressure, or vacuum. This draws the water up into the pump. Condenser vacuum can also be used for this priming. The siphon system is used with larger water systems and uses the water flow itself to pull additional water through the pump system. To a pump. For instance, heated water can flash to steam if the suction pressure is low enough. We can also lose a lot of power overcoming friction of flow if the piping is not adequately sized. Suction is an important part of the total head. If either the suction or the discharge head is changed, for instance by opening or closing a throttling valve, the capacity of the system will be affected. Which brings us to our third operating characteristic, which is capacity. This is the volume, or gallons per minute, that flows through our pump at a specific speed and head, directly by the other two, remember. Pumps have different personalities or operating characteristics, and engineers call for a specific pump design to give optimum results for its particular pumping system. Well, it's about time to see how much information we've pumped into you so far. Page 26 in your Tri-Media book has some questions. Check the answers, and then restart the machine, and we'll give you the correct answers. Remember, page 26. Do that now. Alrighty, let's see how you did on your both piston and rotary are high-pressure, low-volume devices. The centrifugal pump is the heart of our power plant system, as question 3 points out. These pumps move condenser cooling water, boiler feed water, fire protection water, lubricating and control oil, and did you get 3 of these? Good. In number 4, you should have circled impeller and casing. The other parts are important, but these are the 2 principal components, you remember. Well, our next answer, number 5, is technically false. The impeller creates liquid velocity. In this case, we'll accept a true answer also. I hope you said false for number 6, though. Speed does change capacity, but so does any change in pump head. 7 is also false. Packing, unfortunately, requires a great deal of attention, but it is essential to proper operation. Did you mark 8 true? The suction head of a pump can be either positive, liquid level above the suction inlet, or negative, liquid level below the inlet level. 9 is false. Hydraulic couplings will take angular misalignment, but it is for speed or torque reduction that these expensive devices are usually applied. And 10 is correct. Different pumps have widely varied operating characteristics, and each application should be carefully engineered. Well, you may review this pump program again if you wish. Otherwise,